Right, in this video, we are gonna go over chapter 6. Chapter 6 deals with the normal distribution. So let's begin right away. Let's recall a normal distribution. We know a lot about the normal distribution. It has the bell-shaped curve. And right in the middle is where the mean value is, right? So mean could be any number, right? It could be 1, 0, 10, 100, so on. And then each mark that we go to the right, we call it going 1 standard deviation, 2, or to the left, we say -1, -2 standard deviation. Now, standard normal distribution has the following four properties. There's a normal distribution and standard normal. It looks very similar. Standard normal distribution still has the bell-shaped curve. However, now it has a restriction that mean value will be 0 and standard deviation will be 1. So in standard normal distribution, where the mean value and the in standard normal distribution, mean will be always equal to 0 and standard deviation is 1. Total area under its density curve is equal to 1, meaning if you shade it in the entire region, the probability value is 1. Notation that we use will be x for the variable, n stands for normal, and then there's two values that we will put it, mean value and then standard deviation. Definition. So this is the next concept that I want to introduce, which is the z-score. What is a z-score? Z-score tells you how many standard deviation the value is above or below of the mean. So that means it's kind of some people like misunderstand and then interpret the z-score same thing as a standard deviation. But z-score tells you how many standard deviation, whereas standard deviation actually tells you like a distance. So a really quick example, let's say the mean value was a 10. Standard deviation was 20, okay? And then we have z-score 2. What this means is we have a mean 10. If you go one full standard deviation, you know that that's 10 plus 20, so this actual value is 30. And then add 20 more will be 50. Now, this actual distance from 10 to 30, the distance is a 20. That's a standard deviation. Now, the z-score 2 means that's 2 standard deviations. So that means I'm looking at the 50. So 2 full standard deviation. So z-score tells you number of standard deviation. Standard deviation tell you the distance. Okay, so I want you to get these two straight. So the way we calculate the z-score is x, the data value, minus the mean divided by the standard deviation. So let's take a look at example 1. This comes from the homework number 3. The systolic blood pressure given in millimeter of male has an approximately normal distribution with mean 115 and standard deviation of 18. Calculate the z-score for the male systolic blood pressure 100 and 130 meters. So let's calculate the z-score. And I'm going to use the bottom one again to kind of visualize what's going on and then double checking. We have the mean value equal to 115. Standard deviation was given 18. So if I were to label the points going one full standard deviation, that will be 115 plus 18, so 133. Adding another 18 will be 151. Adding another 18 will be 169. Also going on the left hand, 115 take away 18, 97. Take away 18, 79. Take away 18 will give you 61. Okay? So let's take a look at 110. 110 is located right over here, right past 97, so somewhere here. So I'm expecting a z-score less than 1, because remember, one full standard deviation, that's a z-score of 1, is a 97, and 100 should be bigger. So I'm expecting a number less than 1. Less than 1, which means negative, right? Negative because it's going to the left. Z score, the formula says x minus mu divided by sigma. X, this is our value, 100. Take away the mean, 115 divided by standard deviation 18. This will be equivalent to rounding to the 2 decimal place. I'm getting negative 0.83. That looks good because I expected less than negative 1. Let's try 130. 130 is located a little bit less than 113, right? So again, I don't go one full standard deviation, so I should have a positive number but less than 1. So z score of 130, take away 115 divided by 18, rounding to the 2 decimal place, I'm getting 0.83. Okay. Part B. If a male friend of yours said he thought his systolic blood pressure was 2.5 standard deviation below the mean, but he believed that his blood pressure was between 100 to 130 meter, what would you say to him? So here's 2.5 standard deviation below. All right, so from part A, we know that 100 to 130 is right over here, right? Right there. This to this, right? This was 103, 130, and this was 100, okay? This was actually 0.83 standard deviation to the right, and then 0.83 standard deviation to the left. So you know that it's not a 2.5 standard deviation below. 2.5 standard deviation below should be going 1, 2, and half right here. It should be somewhere between 61 to 79. So he is incorrect, because 2.5 standard deviation below the mean would give him a blood pressure reading of, now let's calculate that blood pressure reading. I can use the same formula too. Z so Z is equal to, let me use a different color. Z is equal to x minus mean divided by standard deviation. I'm looking for x this time because the reading. I know the z-score was a 2.5 standard deviation below. Below means negative. Minus 115 plus 18. Let's calculate it. Multiplying 18, multiplying 18, I'm having negative 45 equals x minus 115, add 115, add 115. I'm having a reading of 70. That looks reasonable, 70. Correct? 2.5 standard deviation below the mean will give him a blood pressure reading of 70 millimeter, which is below the range of 100 to 130 millimeters. Okay, so that's the concept of z-score. So have the z-scores mean and then standard deviation kind of as a set. Okay, don't think of it as a separate things. Now let's move on to calculating the probability of normal distribution. Using the normal distribution, recall when we deal with the less than and greater than in the past, when we were dealing with the binomial, right? Area to the left will represent the less than, and then greater than will be area to the right. So you could have also interpreted it as a 1 minus the less than. This x, the textbook use x, but it's some k, some x, random x value. Okay. So the function that we use, so I'm gonna follow the exact same structure of binomial. When we use a less than, we use a CDF, binom CDF. So same thing, we are going to be using normal distribution, so normal CDF for both. Normal CDF. Now, binomial CDF, you need to put couple numbers, right? When you use a calculator, NPX. So same thing. For the normal distribution, you need to put some numbers in the order so the calculator knows how to calculate the area under the curve. The way that we are going to put it is these 4 numbers in the order. When you're finding the area, you're going to be using a normal CDF. You're going to be entering 4 numbers, which are your left x value, right x value, mean, and the standard deviation. What is left, right means? So if you have a curve, and let's say you're considering, I'm just making up number, area only on this one, right? Which is probability between -1 to probability of x between -1 to 1, right? Then your left x value will be a -1. Your right x value will be 1 because I'm only considering this much area region. And then your left area begins at -1. And then you stop at right at 1. So that's your left and right x value. Now sometimes you might not have a middle region. Sometimes you might have something like this, where you have to consider all these all the way up to here, +1, instead of just certain region. Then in this case, there's really not a clear x value that starts with. I just start really, really small, right? The curve continues. So I could say -2, -3, -4, -5. So what's the number? So it gets smaller, smaller, smaller. So in other words, it's a concept of a negative infinity. It's just really small number that begins all the way up to +1 that I'm considering. So if you don't have a clear boundary where it says -1 to 1 and it just say less than 1, this case will be, this area will represent probability x is less than 1. Then you would put the no left value as a -10 to the 99, which means really small number. I could ask the opposite thing too. So if I just say this much area, which means probability of x greater than 1, this time I have a left where the green region starts, but I don't have the right part because it keeps going. Then your right value will be just 10 to the 99, really large number. Okay, so keep that in mind, and we will use that when we do the next exercise. Remember when we were doing uniform distribution, you could do the reverse order. I give you the area, the probability value, and you were asked to find the x value. Same thing. I can ask you to find the x value, and we do have a calculator function to do the reverse order. And that function is called inverse norm. Inverse norm will be used to calculate the x value. There are 3 numbers to be entered. Total area to the left, so left area value, mean, and the standard deviation. The area will be given on the problem. So let's try the example 1 and 2. Okay. And feel comfortable with the normal CDF and the inverse norm function. A bone mineral density test can be helpful in identifying the presence or likelihood of osteoporosis. The result of a bone density test is commonly measured as a z-score. The population of a z-score is normally distributed with a mean of 0 and standard deviation 1. A randomly selected adult undergoes a bone density test. Find the probability that the result is a reading less than 1.27. All right, so here's a keyword. I'm looking for probability. So the probability means find the area. So I will be using normal CDF. Okay. Same thing, B. I see the keyword probability, so I'll be using normal CDF. Now in example 2, I gave percent. The problem give you percent. It's asking you to find the bone density score X value. So in this case, you'll be using inverse norm. So when you guys begin the problem, decide, am I trying to find the probability value or the X value? If it's a probability, then it's finding area, so normal CDF. If it's an X value, you will do inverse norm. So let's draw the normal distribution. You already know mean is a 0. Standard deviation is 1, so I'll add 1, subtract 1 each one. You have you want the probability of X less than 1.27. So here's my 1.27. I'm shading in less than. You can kind of predict the value. I'm shading more than half of my bell-shaped curve, so I'm expecting a probability value to be greater than 0.5. Let's enter those numbers. Area to the left X value. My X value is keep going. So I'm just starting at really small X value. So I'll use -10 to the 99. There's no clear start. It just starts really small. All the way up to right. Where do we stop? 1.27. Mean was given as a 0. Standard deviation was given as 1. And you're going to be putting this on the calculator. Oops, I think I forgot something. We want to use a normal CDF, so I forgot to put that. So which means equal to normal CDF and right there. Okay. All right. So let's see if we get an area value that is bigger than 0.5. So let me pull out the calculator. So here's my calculator. You can see that on the bottom, there's a key press history. It's gonna tell you what button that I press in the order, so you guys can follow along. So normal CDF is found under the distribution, so it's in blue. So we press second and bars, and you see the PDF and CDF. This was the same screen that we used for the binomial distribution. So it's the same one, but we use CDF, so number 2. Lower value was a -10 to the 99 or -1e raised to 99. Sometimes the calculator, if you have this version, then you're gonna see that it's already set up into a standard normal distribution. See 0 and 1. Upper value was a 1.27. So you're gonna put 1.27. Paste it. You have 0.8979, right? So rounding to the 3 decimal place, 0.898. That looks good because that was the number that we got, or we were expecting bigger than 0.5. So 0.898. Okay. Part B, find the probability that the result reading is between -1 and -2.5. Okay, so let's do the same thing. I'm gonna draw out the curve. We have 0, -1, -2, -3. Okay, so I am looking for between -1 and then -2.5. Okay, so where's the -1? -1 is right over here, so this much boundary. And the -2.5 is -2.5. Oh, that's even going more. -2.5 right there. -2.5. Okay, so I'm looking for this much area. Okay, so what's that mean? Probability of x between. Now, here, if you look at it, your left area begins at the blue, right? Blue is your left boundary. Green is the right boundary. So your number actually switches. So don't just put -1 to -2.5. -2.5 and then less than -1. Okay. The order doesn't matter because you need to put left, right, mean, and standard deviation. Okay, so this is finding the probability, so I'll use normal CDF. 4 numbers in order. Left, again, the blue one, it begins at -2.5. This time you don't have the negative infinity because there's a clear starting value. All the way up to -1. And then we have a 0 and 1. This time you do know that I'm expecting a number smaller than 50% because your area did not get shaded in halfway. So let's see what we get. So you have second vars, normal CDF, lower means -2.5, so -2.5, upper is -1, so let's clear -1, and then mean and standard deviation 0, 1, pace, done. 0.1524. That looks right. I'm getting less than 0.5. Point 1524. Example 2. Use the same bone density test score described in example 1. Find the bone density score corresponding to piece of 95, the 95th percentile. That is, find the bone density score that separates the bottom 95 from the top 5%. All right, so here is my curve again, 0. And then bottom 95 to top 5. So I'm shading bottom 95, top 5%. So I'm looking for this value k. Where's that x value? Where's the k value that separates such that below that k value represent 95% and then above represent the top 5%? This is finding the value, x value. So I will be using an inverse norm. You see that? Finding x value inverse norm because I'm not calculating the probability. So inverse norm, 3 number, area to the left, mean and standard deviation. Area to the left, mean and the standard deviation. Okay. So inverse norm. Inverse norm. area to the left of this K value will be to the left. Oh, this is a 0.95. Don't put 0.05, 0.95. Mean is 0 and standard deviation is 1. Okay. You see that graphically, I should have a positive score for the K because I'm going past the 50 mark, right? Because right at the center is your 50 mark. Okay, so let's check. Now, I'm going to show you with this, I'm going to show you two type of calculator because I don't know which one you have. But the first one is this one, the TI-83 and the 84 earlier version. We'll see this part here. So if you go second bars, you have the inverse norm, and there's those three number clearly for you. Area to the left was a 0.95. Mean was a 0, and then standard deviation was 1. Remember, it was a positive, the one that we expected. 1.64, rounding to the 2 decimal place. So that looks good, 1.64. 1.64. Now, some people have this type of calculator where you have an option. So this one right over here, let me clear everything. Let me even clear the screen. So some of you guys have this type of calculator. You go to second verse, inverse norm, and you see that there's all other option, tail, left, center, right. Now this is a nice one because sometimes the problem will not always give you the left value of a area. Sometimes they might give you the right, and then if you had the older version, the first one, you had to calculate the left one. But if you have this one, you can choose. So if you have this one, you can do it either way. Let me go back to the notes and then comment about what the tail means. So if you go back to your question, the 95 represent the left value, left area to the K, and then 0.05 represent really the right side of your area. So the tail, remember there was a 3 selection, left, center, right. So technically you can use either 0.95 or 0.05 and you're gonna get the same answer. If you use 0.95, what you have to do is you have to make sure that you let the calculator know that you selected by putting left. Don't forget to do that. Don't put right if you put 0.95. If you use 0.05, you can still get the same answer if you want to use 0.05. Then your area will be selected as a right. It's important that you select the correct one. Then you're still gonna get the same thing, 1.64. So let me show you, okay? So it was first one I like to do is the normal one, the left one. It was a 0.95. Mean was 0. Standard deviation was 1. And then it was a left tail. You're gonna get the K value 1.64485. Yep. And then you have a second option. But if you choose to use the right function, then you have to give a right area value, 0.05. 0, 1, make sure you go to right and then paste it. See, you're gonna get the same thing. So I wanted to be clear on if you have this calculator, this TI-84, the older version, the newer version one, you have an option to choose which one, and you can even find the center value. Okay, so that's pretty nice because the problem may give you the left or the right or the center value. Okay, if you do not have that left, center, right, you can, remember I show you that you can still get the same answer, but you just always have to put the first number as the left one. So that's why I put it on your notes, total area to the left. Okay, so don't forget, you want to put the left value.